Hello, welcome to the second demo of our Concert collaborative audio production tools. This demo is kind of a re-examination of some of the things we showed at the Linux Audio Conference this year, 2018, in Berlin. So, what we're going to show you today is a rudimentary user interface for our tools, and that really shows us as developers the data model in an interactive way, what's going on in our system. This isn't representative at all of the final user experience we're aiming for, but it will show you a bit of the state of where our development has got to. In our rudimentary UI, we've got a timeline widget, so I'm going to show you a mock-up of that first so you get a bit of a feel for what that can do and can show. It's what you'd expect from a normal user interface for a digital audio workstation, where you've got a time axis left to right, and you've got streams of data that you can represent vertically. You can scroll around and you can zoom, and it keeps everything in proportion with itself, and it keeps the cue point in the correct place and things like that. Or playhead if you're playing. And we've got this in our rudimentary UI, but we've got no real data backing it up. So just bear this mock-up in mind when you're seeing our actual UI that's backed by real data. Just like with our previous demo, we are having a whole bunch of components that are talking to each other across the network, and they could be running on separate machines. The central component is our relay or our API broker that sits in the middle of the communication pattern and fields messages to whoever needs to hear them. And we're going to start our audio engine as well, which is the component that is actually handling the audio and producing sound. We need to start Jack, which is going to connect the audio from the engine to our sound card. And we've got a new component here today, which is a JSON WebSockets bridge, which allows the web browser to connect in a real-time or event-driven way to the backend. So that those components are all running. And let's go ahead and load a web UI that we're serving from the same machine that just has some JavaScript that will connect over the WebSockets bridge to the relay. So we can see in the user interface that we have the timeline view, just like we showed in the mock-up, which we can scroll and zoom still, and then we have a few bits of other data. We can see some information about who's connected to the user interface and what their kind of delay from each other are, so that we can synchronize in time loosely. We also have a transport state drop down here, and this is being completely generated from the metadata that the relay has sent out from the engine when we connected. So right now we just have a drop down of all the options of transport state that are available, and we can choose which one we want, and the user interface is not really aware of any particular semantic meaning around those. So if we go ahead and select that we want the transport rolling, and we click the apply button, you can see a couple of things have happened straight away. The playhead has started moving in the timeline view, and that's sort of smoothly animated with CSS. The audio has started playing, so we're in sync with the engine. We are processing audio. And you might not have seen it when we changed the play state. The previous state was shown for a little while, and that's because this user interface is having to handle not only exactly what's happening right now, but it's got all of the history of what's happened, and specifically you can't see in the user interface, but it also handles attribution, so who has been changing pieces of information at particular times. So if we go ahead and stop the transport just with the same drop down and apply, you can see the change in transport state come up in the UI. And just to reiterate, this isn't the experience that we want to have for users when they're finally using it, but it's enough for us now to see that we can model all of the data in the UI. So let's go ahead and make sure that whilst we're playing, we can connect another client, because this will show you another nice aspect of our data model. The second user interface that appears has the playhead in a state that matches the first user interface, but the engine has not changed what it's doing, so it hasn't broadcast any more information. It's just that when the second client connected to the relay had cached the particular information that it needed to send out to let the client know exactly where the playhead was and when we started playing. and you can see that these user interfaces are completely independent in terms of their views, because we can zoom one and leave the other alone, and they show different views but the same information. So if you recall from demo 1, we showed you could do things like stop the playback in one client and continue it in another. Well, now we've implemented seek in the engine, which is a feature that's kind of implicit in this demo. You can see that we can do things like stop in one client, seek in another, and then continue playback. And all of the information from each client just stays completely in sync because of how we've put the software together. There's another interesting aspect here, that you can have multiple widgets in the same UI that are sharing the same data model, and they too can always stay in sync by the way we've architected the software. So for example, if I stop playback here and then I try and edit the time of the cube point in the top user interface and set it to a particular time, I can then see the cue point move in both, and we can start playback in both from a known location. And this all should just happen seamlessly behind the users, and they really should just feel they're interacting with one single thing, no matter which user interface they're looking at. So that should give you a flavour of where we've got to. As always, the audio for this narration was recorded on Audio Engine as well, which just goes to show everything is still working nicely. And if you're interested in more detail about how everything under the hood here is hanging together, we go into quite a lot more detail in our talk that we gave at the Linux Audio Conference, which is in the description below.